Hey, it's Jag. Just kidding.
Yeah.
Well, back in the shop. Finally, more than a year after the flood that destroyed the electronics shop, I'm back here starting a new electronics project. Quite a change. So when I was 13 years old, I started playing guitar, and at about the same time I got interested in electronics. Those two obsessions fed each other, and I immersed myself not only in learning how to play guitar, I also studied as much as I could about the equipment around guitar playing, especially pickups, wiring, all of those things, what made an electric guitar output sound. One of the things that I heard about was hand-wound pickups and how good they were supposed to sound. At the time, I thought hand-wound meant no machines or tools. So I thought I could really benefit from having hand-wound pickups in my guitar. So being 13 years old and not really knowing too much else, I took the pickups out of my guitar, which I don't know if they sounded good or not at the time. They probably didn't. I was playing an inexpensive El Degas Les Paul copy. The guitar played well, but the pickups actually were really crappy. I do remember taking them apart. My idea was that I would unwind the pickups and then wind it back onto the pickup by hand. I got about 100 or 150 winds off the pickups before I realized this wasn't something I was going to do or stick with. As I would try and unwind it and wind it onto another spool, it would break. So I ended up throwing those pickups out, and I got a set of Ibanez Super 70 humbuckers. I wish I still had those. They sounded great. I definitely would have them in a guitar today if I still had them. Later, I learned that what hand wound actually means is hand guided. So what is a pickup winder then? What do you hand guide with? Pickups are wound on a pickup winding machine, or more specifically a coil winding machine. The machine is either hand controlled or CNC controlled. Hand guided means that the operator is controlling everything about the winding process. Here's my Schatten Coil Winder. It's a very simple device, really. It's just a motorized bobbin winder and a guide for the coil wire. There's a counter up here, and there's a counter reset. So every time you start winding your pickups, you of course want to start at 0, and you're going to wind your coil with however many windings you determine you want for your pickup. We can wind pickups either clockwise or counterclockwise. If you're making a pickup, you have what you would call a north coil and a south coil. They are both wound in opposite directions, and they both receive opposite magnetic polarities. And that's what makes a humbucker. When you're winding single coil pickups for something like a Strat, you will have your neck and your bridge pickup wound in one direction, and then the middle pickup is wound reverse to those for the same reasons. In position 2 and 4 on the Strat, you will have also humbucking effect. If you've ever noticed that on a Strat, the hum goes away when you put it between 2 and 4. When you're winding a pickup, you take your pickup bobbin and you stick it to the spindle here, the bobbin spindle, and then you bring your coil wire up, usually from the floor, over this guide onto the coil, and you start your winder. You start very slowly, making sure that your wire is going evenly on the bobbin. The coil wire is very delicate and it can break very easily. So you're tensioning that wire between your thumb and finger very lightly, just to make sure that as the wire winds onto the bobbin, your bobbin isn't really loose. You also set your guide and watch that as you're guiding left and right onto the bobbin, that the wire isn't coming and going either behind the bobbin or in front of the bobbin. Once you're happy with how well things are winding, you bring the speed up. And when you're first winding, you might want to go a little bit slowly until you get comfortable with how it works. Once you really know what you're doing, you can go very fast, and then you just guide your coil wire back and forth on the guide until your bobbin reaches the number of turns that you want. So once you reach the number of winds you want, you cut the coil wire, you take the coil off, and you very carefully tape down the two ends of the coil wire until you're ready to solder the leads on them. So that's a pickup hand winder, and as you see, as the person winding, I'm in control of how fast the wire winds onto the bobbin, and I'm also in control of how evenly the wire is laid down on the coil. There are different methods for laying your wire down on the coil. If you're interested, look up scatter winding and any information you can find on that. That can be very tedious work, hand winding pickups, if it's your job. If you're doing it for fun, it can be very relaxing and peaceful. One thing about hand winding pickups, it's very hard to make your pickups consistent. Winding different amounts of wire onto the bobbin, laying the wire down, all affects the way the pickup sounds. So it can be very difficult to have very consistent results in your pickups, have one pickup to the next sound the same or very close to the same. So the industry moved on to winding pickups on CNC pickup winders. So CNC, computer numerical control, is used to automate a large number of manufacturing processes. If a process is repeatable and relatively simple, a computer system or computer controlled system can be programmed to perform the bulk of that task. I say relatively simple because in this digital age, more and more complex operations are able to be completed with the aid of computer automation. The rise of artificial intelligence will only further that more, making it possible to automate even more complex tasks and operations, and the systems will actually be able to react to variable conditions. It's really easy to apply CNC control to a pickup winder because you have a very limited number of things that the machine needs to control. Really, it needs to control the start and stop of the winder, the direction it's winding, and to guide the coil wire. That's what we're going to do building the Highline Guitars CNC pickup winder. Given that we're all YouTube content creators and YouTube has now been around for quite a long time, there's no shortage of creators doing just about anything you can imagine and showing you how to do anything you imagine. Of course, being interested in woodworking, electronics, amplifiers, guitars, I follow a lot of different YouTube content creators. When it comes to guitar building, one of the most helpful YouTube channels to me has been Highline Guitars. I bring Highline Guitars up because, as I mentioned before, the CNC pickup winder we're building are from the Highline Guitars plans that Chris makes available on his website. There is an introduction to this CNC pickup winder project, and he also has a series where he builds the winder as well. I'll put links to that in the description below. So if there's already a build series and plans are available and it's already been done before, why am I doing this? The reason that I'm doing this, there's a few reasons. For one thing, in Chris's own words, this is not a simple bolt-it-together DIY project. It's an advanced DIY project. Do it yourself with an emphasis on yourself. Highline Guitars operates completely on their own. Chris does everything from scripting, shooting, editing, and posting the content. And he just doesn't have the time, in his own words, to offer the sort of support you might need to build the CNC project successfully. There are many advanced things you need to know and understand to to build this project. For example, flashing an Arduino Uno 1 card with the software needed to control the winder. I also operate on my own. I do everything myself, shoot, edit, post, all of that. And I really don't have time to provide support for that kind of thing either. But why I'm doing this is to offer another perspective on the build, my perspective on the build, and share my experience of building it and solving any issues which might come up. There is one I already know about before starting that I will mention a little bit later in this video. That said, as always, if any of you are building along and you have questions or you run into something sticky, feel free to post questions in the comments, and I will do my best to answer. If it's a simple little question, you know, hey, how come this part isn't working? I can say, well, maybe it's this, maybe it's that. Take a look and see. But at the end of the day, you are on your own building this as well. Let's dive into the build. For the remainder of this episode, I'm going to cover the main mechanical and electronic components you'll need to build the winder. I'll cover the other materials you will need for this build in the next video when I actually start building the winder. There is one thing I want to say before we go too much further along in this, and that is if you are interested in building the Highline Guitars CNC pickup winder and you're going to build along or watch my series and Chris's series and then build it yourself, I will not make Chris's plans available or the software to control the CNC, and I'm not going to be too specific about part numbers. Chris has put a lot of work into putting the plans together, and he makes them available for a very reasonable price on his website. So please go over to his website if you're going to build this winder, buy the plans. They also include the software to generate the G-code to run the winder, and that's the only way that Chris gets repaid for his work. So again, I will show you these parts, but I'm not going to list part numbers. Please don't ask. Get the plans and refer to those. As same thing, if you're building along and you haven't bought the plans and you manage to build the winder, but you don't have the software to generate the G-code, I will not provide that to people. Chris provides that on his website. I'm also not really going to describe in this video what the function of all the parts is. That will become obvious as we build. So I'm basically just showing you the main electronic and mechanical parts here. Chris, as I said, does specify part numbers for those in the plans, so refer to the plans when you're ordering your own parts. Also, Chris includes links where you can order most of the parts for the build, and those are included in the plans. Those of you in the US probably won't have any trouble obtaining those parts via those links. If you're in Canada, like me, or somewhere else in the world, you may have some trouble getting some of those items, at least through the links Chris provided, and that was my experience. So as I go over these parts, I will also tell you where I did manage to get the parts. So being in Canada, when I order from Amazon, I always order from Amazon.ca, the Canadian Amazon site. But as any of you who are in Canada or even somewhere else in the world, Europe or the UK, as you will know, sometimes things that are on Amazon US, Amazon.com, are not available on your country's version of Amazon. Usually when that's the case, you can order the part through Amazon US, but you have customs and extra taxes and duties and things like that. So whenever possible, if I'm ordering on Amazon or ordering anything, any parts, I try and get them within my own country first to try and save on those duties and fees. So I'm going to start with two things that I couldn't get anywhere but on Amazon.com, the US Amazon site. And even one of those I couldn't get, and that's the problem to solve that I mentioned earlier, the first problem to solve. The first piece from Amazon US that I ordered is the Sestos digital counter. It comes with a faceplate mounting ring, so can help you keep it in your project. And that I could only find, at least easily anyway, on Amazon.com. So I ordered that, and it cost me probably a little more than it would have if I had been able to get it locally. The next thing that was available on Amazon.com, but they will not ship to my country, is the coil wire tensioner. So as I said, when you're hand winding, you tension the wire between your thumb and fingers yourself, and you can guide it that way. But what would a CNC, a machine that does the job for you, be if it didn't tension the wire? You know, if you had to sit there and guide or tension the wire anyway, why would you even be building a CNC machine? So the coil wire tensioner that Chris specifies, I don't know much about coil wire tensioners, but it seems to be a pretty big industry. There's lots of different coil wire tensioners. There are other tensioners I could get here in Canada, but I don't know if they're equivalent. I don't know how to spec them out or figure out what's a good replacement. So down the road, if I figure that out, I will buy a coil wire tensioner. It's also one of the most expensive parts. Even if I could have got the coil wire tensioner from Amazon US, by the time I landed it here, it would have been about $200. So I am going to be making my own wire tensioning mechanism. The next things on the list are things I was able to order directly from Amazon.ca. So you're going to need cooling fans. Comes in a 4-pack, at least here when I ordered it, and a cooling fan guards. This came in a 2-pack. Also, I was able to get the DC electric motor for winding the coil. You also need V-groove bearings. I got those in a 10-pack. I think I only need a couple of those, so I got spares. Actually have some ideas what to do with the extras anyway. You also are going to need a mini lathe double bearing live center. The function of this is to hold the coil onto the spindle when the coil is being wound. So you could do other things you could do without this, and you could use double-sided sticky tape to stick the coil to the spindle plate. But I thought this kind of looks cool, and it makes the project look a little more high-end, I guess we'll say. So the other things I was able to get on Amazon Canada was the power supply. You need a female power plug, one that has the screw terminals to screw the wires to that go off to the various other pieces. You can order these separately, but my power supply actually came with one, so I didn't need to order that separately. Probably the thing that I had the most trouble sourcing was a Z-axis linear slide. So this is the linear slide I ended up with. It's exactly the spec that Chris spec'd out in the plans. The purpose of the Z-axis linear slide is it guides the coil wire onto the coil. This was, like I say, the most difficult part to find, mainly because I wanted to get exactly the size he specified. They're pretty easy to find in longer versions, and I'm sure they will work just fine on the project. But I wanted to do my best to build this as close to the spec he specifies. On sparkfun.com, I got about 5 of the things that you need. We have Pololu Universal Hub. This is where your plate, your bobbin plate, will be mounted onto the spindle using this Polalu universal hub. There is an Arduino Uno R3 controller board. This is really the main brain. This will be what will deliver the intelligence to the machine. We also need some Arduino header pins. This is so we can connect our various wires going off to other controller boards and the power coming in, etc. There is a photo interrupter and a photo interrupter breakout board. This detects, it's how your winder knows how many winds you have on your coil. The breakout board just lets you mount this and solder it to its control, or wire it to its control. So those last 5 items, I got them sparkfun.com. You can also get them on Adafruit, or most of them, so not difficult to come up with. The next thing is the Cytron controller board, and I got that through Cytron.io, which is India, I guess. The British Indian Ocean Territory, I guess, is what .io means. In the kit, you get some little mounting screw terminals and a little wiring harness. Here's what the controller board looks like. So this next one, which was a little bit more difficult to find as well, is the Synthetos G Shield. This I got at synthetos.myshopify.com. I don't recall if it was the only place I found it. I know that when I was looking for the parts, I looked not only where could I find these parts, but was there another place where I could get it at a little less, a little better cost. So the last of the electronic components and the last part that I'm going to talk about is a 220 ohm resistor. I'm not going to show that a 220 ohm resistor is a 220 ohm resistor. You know when you got one. I didn't even have to go buy that. I have it in my bins. For amp building, I have quite a good selection of all of the common values of resistors. If you need a 220 ohm resistor, I generally order those things from Mouser.com. So you can go on to Mouser, you can order that. I'm pretty sure you can get them on Amazon as well, and they're not very expensive. So I didn't do a breakdown, an accurate breakdown of the cost of all of this. I just kept the running total roughly in my head. All of these parts came to roughly $500 Canadian, including shipping, taxes, and customs fees. But that $500-ish, I think it was about 450 really, doesn't include the cost of the coil wire tensioner, which I am not able to get the exact one here. Amazon.com will not ship that to Canada. I don't know why. Maybe there's something real secret about them. Who knows? Like I say, that's a whole world I didn't even know existed. At any rate, the coil wire tensioner landed, had I been able to get it off Amazon.com, would have been around 200 Canadian dollars. There's a few of these parts you don't actually need to go with. The coil wire tensioner, as I say, is one of them. You can save a couple $100 by making your own tensioner. If you watch Chris's build series, he explains why he went with the coil wire tensioner he went with, and it makes sense. And as I say, I may upgrade this to that down the road, but I'm going to go with a self-made tensioner. It's a lot simpler and not very expensive to make at all, a couple bucks in parts really. And I'll see how that works. If I find I'm breaking a lot of coil wire, then I'll revisit the coil tensioner. Another part you probably don't really need to get, and I've already said it before, is the live center. You can just as easily stick your coil with double-sided tape onto the winding platen. So that's it for this episode, the first episode in the build of the Highline Guitars CNC pickup winder, my winter 2024 build. Next episode, I will start the build. I will be getting all the rest of the parts together, cutting the parts for the cabinet and the mounting platform, and maybe making the platen. We'll see how far I get on that, and getting together all the little screws and nuts and bolts and things. Chris includes all of that information in the parts list as well. All the screws you need, the sizes, the lengths, whatnot. I am going to, for that part of it, go with what I've got here first. If I really need to go buy something to put this together, I'll do that. But I've got lots of little screws and nuts and bolts and parts. I don't really think I'm going to need to specifically order those things for this build. But again, if you don't have that stuff, you'll want to get that together. You can order that through the parts list in the plans. I'm really looking forward to this build. The first thing that I am planning on doing when I get the winder built, I'm going to wind a set of pickups for the Pharaoh, my GGBO 2022 guitar. And I also will be winding 2 pickups for the next guitar project I'm going to do, which is completing the Butch Jr. build. And I want P90s in that one. Butch Jr. will be a guitar build I probably will start very late spring or early summer. After I do this build, the CNC pickup winder build, which I'm hoping will be done by the end of March, I'm going to do a real electronics project and build a bass recording preamp, something I've promised to my brother for a lot of years, and I'm going to finally get around to that. So, like always, thanks for watching. Like and subscribe. Check out my band One Soul Thrust. The links, as always, are in the description below. And until the next video, we'll see you.